Hi, and welcome to this video about snapping. Today I'm going to delve just a little bit deep into the snapping menu you see at the top of your Blender screen. This tutorial will not be specifically geared for beginners, so keep that in mind. Also, it's good to mention that this will only cover snapping when it comes to moving an object or an element. So a big thing when it comes to snapping is that it can differ whether you're in object mode or edit mode. Why? Because in object mode, we have access to things that we don't have access to in edit mode. So for example, in object mode, we have access to the origin and we can use it as, in this case, a transform pivot point, and we can use the object's local axis, the one that you can see right here. However, in edit mode, you do have access to the local axis, but you can't really alter it, right? You know, you can rotate the cube however you want, and the local axis will still be the same, right? And even if you go to origin point, it'll still be the same. And in object mode, you can't really alter where the origin point is, and you can't really use it for your advantage. So that's why snapping can differ whether you're in object mode or in edit mode. And that's basically why throughout the tutorial, I'm going to show you how to do something in object mode and how it works in edit mode, specifically with align rotation. All right, we'll start with the easiest snapping type, and that is snapping to an increment in the grid. I'm going to turn on this little magnet, which allows me to snap while transforming. And so if I go down to top view, you can see as I move the cube, it snaps to increments in the grid. And as you can probably guess, it's based on your view, right? So if you go, if you really zoom in, you can snap to little increments in the grid. But if you go far back, you can snap to bigger ones. Now, increment has an option which allows you to snap to the absolute grid snap. Well, in this case, it means snapping to the actual lines instead of just snapping to increments, right? And so if you turn that on, you can see that we're actually snapping to the lines you see on the grid. Also, a good thing to remember is that absolute grid snap depends on your origin, right? So if you move the origin to the side, you can see that if you go back down to top down view, you can see that it doesn't necessarily stick to the lines as nicely as we saw it. And that's because it depends on the origin, and the origin is all the way back here. So what we could do is, if you have a perfectly symmetrical object, you can set it to the volume. Or if you want to snap with a specific corner, like this one, what you could do is set, let's say, the origin point to this edge, right? So if we snap the origin to this 3D cursor, which is on the edge of this cube, and then you can now see that it snaps nicely to the grid. All right, the second option in our snapping menu is snapping to vertex, right? And as you can see, we have a smaller cube over here, and so let's actually make it smaller. And so as you can see, when you move the cube, you could see that it nicely snaps to the vertex of that bigger cube, right? And the important thing to see is that when we moved from increment to vertex, we got a whole new array of menu options. And those I'm going to cover in other snapping types because then they're going to be easier to explain. However, what I'm going to cover with each snapping type is how align rotation works. So what align rotation does is that it rotates your cube to align with whatever you're snapping to. So in this case, we're snapping to a vertex, and what it does is that it aligns our snap element to that vertex. Now, how does that exactly work? In the case of snapping to vertex, align rotation in object mode, that's important to remember. In object mode, it rotates our snap element to the vertex normal. So in this case, if we go to edit mode, and I've turned on vertex normal over here, you could see that the vertex normal is pointing that way, right? In that general direction. And if you go to our snap element, right, and we go to options, and if you don't see options over here, you can go to view and turn on tool settings. And so if you go to options, turn on affect only origins. You could see that each object has a object local axis, right? And so, as you can imagine, when we rotate a cube, actually, let me turn that back off. When we rotate a cube, the object's local axis rotates along with it. And if you could probably guess, this is what helps determine how our local axis looks like. So as you can see, the z local axis is pointing that way. And when you try to move it along the local z, as you can see in the top left corner, whoops, let me turn that off. You could see that it moves in the same axis. And so what aligned rotation does in object mode is that it takes the z coordinate, the positive z coordinate of your snap element, and it aligns it with the vertex normal you see here. So they're moving in the same direction. So let's test that out. Let's move our cube and snap it to this vertex. And as you can see, the positive z coordinate is going in the same direction as the vertex normal. So I just showed you how align rotation works in object mode, but how does it work in edit mode? So when you go into edit mode, you can't really depend on your object's axis anymore, right? Because you're not moving the object, you're just editing the mesh technically, right? And so to the best of my knowledge, but how align rotation works, let's turn that off. How align rotation works in edit mode is that it calculates the resultant vertex normal of whatever you're selecting. So in this example, it takes every vertex normal and calculates a resultant vertex normal based on them. And then it aligns that to the vertex you're snapping to. For example, let's take the face of this cube and let's subdivide it many times. As you could probably guess, the resultant vertex normal is probably going to be pointing in that general direction. So when we go ahead and take the whole cube and try to snap it to the vertex, as you can see, it snaps it in a way where the resultant normal, in this case, which is generally pointing in that direction, and it snaps that resultant vertex normal to the vertex normal of whatever you're snapping to, right? Now, snapping to edge works in a similar way as you'd expect, and what it does is that it takes your source element and it snaps it to the edge of whatever you're hovering around. However, a difference between edge and vertex snapping is that with edge snapping, and I'm going to use an icosphere for this one. Whoops, let's actually bring it forward. A difference is when you have align rotation turned on, what it does is that it rotates the object such that it's parallel, such that its z coordinate is parallel to that edge. So if you go down to top-down view, you can see that the z coordinate, the object's z coordinate is parallel with the edge you're snapping to. All right, moving on to face snapping. It works in a similar way as you'd expect. It takes your source element and it snaps it to the face of your target element, right? Now, it gets interesting when you turn on align rotation on. So you're still in object mode. And so what align rotation does is that it takes the z coordinate of your object and it aligns it such that the z coordinate is parallel to that face's normal, right? So if you hide the cube for a second and we go into edit mode and we turn on face normal, you could see the face normal is pointing that way. And if we unhide the cube, you could see that its z coordinate is pointing in the same parallel direction, right? Now, when we go into edit mode, it works similarly to what I explained before, and it uses the resultant vertex normal. So let's turn on vertex normal actually. And if you subdivide this face, you can probably guess that the resultant normal is pointing that way. And so when we select the whole mesh and we try to align rotation while in edit mode to a face, you could see that the resultant normal is flowing in the same direction as that face normal. All right. Face snapping is when I decided I'm going to explain the rest of these menu options because in my opinion, they're easier to understand. So let's start with closest. And as you can imagine, it snaps the closest point on your mesh to your target element. So in this case, let's take this cube and, for example, let's, inset it, extrude it a little bit, and actually let's poke it, right? And let's grab this vertex and move it forward. Now, as you can see, I've created something that looks similar to a key, I guess. So when we try to snap it to a face, to have a line rotation, let's turn off a line rotation. You could see that it snaps the closest element, which is this vertex, to your target element, right? Now, center snapping is pretty interesting. Why? Because as you can see right here, it uses the center of your transformation, right? It uses the transformation center to snap onto the target. In this case, our transformation center, and let's actually rotate this object, our transformation center is this origin point. Why? Because we're in object mode and our transform pivot point is set to median. In object mode, median refers to the origin point, right? In edit mode, it refers to something else, but in object mode, it refers to the median. So in this case, our transformation center is our origin point. So when we go ahead and snap to the face, you can see it snaps perfectly using the origin point into the face. Now, it gets a little bit interesting when we experiment with different transform pivot points that could affect our snapping. So in object mode, bounding box works in a very similar way to median, and it basically works by taking the origin point. So in this case, I've set the origin point far back behind the object, and as you can see, when you try to snap onto the face, it snaps using the origin point and not the bounding box around your object. However, when we go into edit mode, right, and we select the whole mesh, what it does is that it creates a bounding box around whatever we selected, right? And it uses that bounding box to snap onto the face. In this case, it uses the center of the bounding box to snap onto the face. Now, it gets even more interesting when we set our transform pivot point into our 3D cursor. In this case, our transformation center is this 3D cursor over here, right? And so let's, for example, set the 3D cursor all the way over here. And so when we try to take our object and snap it onto the face, you can see that something weird happens. And what happened basically is, how I like to imagine it, is instead of taking the object, what it did is that it took this 3D cursor and snapped it into the face, and it moved your source element along with it. In this case, I mean, it's not snapping the 3D cursor, but you can imagine it as if it's snapping the 3D cursor. So let's reset the transformation. And so as you can see, to snap the 3D cursor to that face, you move it down on the x-axis and a little bit on the y-axis, right? So when we go ahead and snap the object, you could see that it does a similar thing, and it moved it along the x-axis and a bit on the y-axis. The same exact translation, right? Now, moving on to median. As I mentioned earlier, median, let me actually reset the origin point. For median, in object mode, it just uses the, the object origin, right? And as I shown earlier, it just uses the object origin. It doesn't really matter what your transform pivot point. It could be 3D cursor, and it will still use the object origin. However, it gets interesting when you're in edit mode, right? And so let's, for example, take this face and subdivide it a whole lot, right? And when you try to take this mesh and snap it onto the face, you can see what happens. It uses the median point of the mesh, right? Or of your object. And how I like to imagine it is that if you could take all of these vertices and you can find the middle, right? The median point of all of these vertices, it uses that to snap onto the mesh. And so moving on to active, and you could probably guess, it uses the active element to snap onto your target element. So for example, if you select these two keys, right? And you can see the active element is this one, right? It's this object. And if you try to snap it into the icosphere, you could see that it snaps it using this this active object, right? Works the same in edit mode, but you could use the what do you call it? The active vertex in this case. So if we select this vertex as the active vertex and we try to snap it onto the face, you can see that it snaps it using that vertex, that active vertex. Now it gets interesting once we explore the other menu options over here. And we'll start with backface culling. And I'm gonna head into edit mode just so you can see. So what backface culling does is that it culls all the back faces from snapping, right? So in this case, you know, every face had a front face and a back face. So if you turn on face orientation, you could see that these sides of the faces over here are front facing. But if you go inside the mesh, you could see that the other side is back facing, right? And so what it does, what backface culling does, it culls any face that's back facing, i.e. the red part that's back facing from snapping, right? You can't snap onto it. And so to demonstrate this, what I'm gonna do is I'm gonna select these three faces actually. And I'm gonna turn their face orientation upside down. So now, as you can see, these faces are now back facing, right? And so when we take this object and try to snap it onto them, you could see that it doesn't snap. It can't snap onto them, right? It's not snapping. However, as you can see, it snaps normally to the front face, to the front facing faces, but it doesn't snap onto the back facing ones. And so that's what backface culling does. Now, what some of you may know is that you can actually turn on backface culling from the menu options over here, right? And so if you flip these options, if you flip these faces into back faces, you can see that they turn invisible. You could actually start seeing through the object. And that's what backface culling in the options menu over here does, right? It hides any back faces, right? And that could help you. I think it could help reduce, increase performance actually. But in this case, it's application to snapping. As you could see, when you try to take this object and try to snap it onto these faces over here, all of a sudden we can't snap onto them anymore. We can snap in these faces, but we can't snap onto those faces. So what backface culling does over here is that not only does it hide back faces, it silently applies backface culling, right? You don't see it, it's implicitly applied onto the object, right? But in this case, the only difference between using this option to avoid snapping into back faces and using this one is that in this case, you could see the back faces and you won't snap onto them, but turning this off and turning backface culling from that menu option over here lets you not see the back faces and also not snap onto them. In previous Blender versions, turning this on just made the back faces invisible and you could still actually snap onto them, as you could see in the following video. Now, what project individual elements does is that it projects each individual element, so in this case, it actually makes 3 different keys, and it projects each of these 3 different elements onto whatever it's snapping to. For example, let's try to snap these keys onto the faces of this icosphere. As you can imagine, what it does is it projects each individual element to the face of your target object, right? So in this case, we're face snapping. And as you can see, each individual element is projected onto the face of this icosphere, right? In edit mode, how it works is that it takes the vertex of each object. So for example, if you go into edit mode and try to snap onto the face, you can see, you know, there's a bit of a glitching effect. Why? Because it's taking each vertex and projecting it onto the faces of this icosphere. Right? It's going crazy, but that's what you'd expect. Now, there's many options that you won't see over here that you'll only see in edit mode, and that is project onto self. And it's pretty intuitive. What it does is that it allows you to snap onto the mesh itself. So let's say we're using this mesh to snap, and what it allows us is that it allows us to snap onto our mesh itself. And so normally, since this cube is actually part of the same object itself, normally if you have this turned off, right, project onto self turned off, you could see that we can't really snap onto the object itself, right, onto the same object. However, when you have it turned on, project onto self, we can start snapping to the same object. Now, snap to volume is a bit of a unique one, right? Because it's a bit difficult to understand at first, but it's very useful. It can be very useful. So let's imagine you have this very long rectangular prism, and you have this icosphere, and you have this camera, right? And let's say we are looking at the icosphere through the camera. Actually, let me turn this off, right? And we're looking at the icosphere and the rectangular prism below it through that camera. When we go to snap using volume, you could see that, I mean, as you can imagine, the icosphere snaps to the volume of the object. But how exactly does that work? How I like to imagine it is that if you go into side view, right, and you draw a line all the way from the camera to the object you're snapping to. And as you can see, this is the first point it touches the snapping target, and this is the second point it touches the snapping target. What volume does is that it automatically finds the center of these two contacts. So let's say this is contact 1, this is contact 2, and what snap to volume does is that it automatically finds the center of these two contacts, and it snaps your source object to that center. So, for example, if we head into side view, right? Actually, that's inverted. If we head to side view, so we're looking at the icosphere and the rectangular prism directly from the side. You could see that when we try to snap the icosphere into the cube, you can imagine what it does is that the icosphere will be centered exactly in the middle. It's because this will be the first contact, and this will be the second contact, and snap to volume will automatically take care of finding the center for us and snap the icosphere right in the center, as you can see. Now, an important caveat to remember is if your object is not as perfectly symmetrical as a cube, right? So what I did was I added a plane into this object. That plane is part of the same object, and what I did, I just added a plane onto it. Now watch what happens when you go into orthographic view, right? And we try to snap this icosphere into the object. All of a sudden, it's not in the center anymore like it used to, but it's actually in the center of these two contacts. So that, in this case, if we grab our annotate tool, this would have been our first contact. This would have been our second contact. And volume automatically finds the center for us, which in this case, is right here. So now that we have a general idea of how it works, I can be a little bit specific with the terminology I use. So when I drew that line from the camera all the way to the object, I was specifically referring to the depths of your view. So, for example, let me take that annotate line away. If we click the icosphere and head to view, you can see what the depths I was referring to was. So that's the depth. It's the coordinates of your view space, right? And so what it does is snapping to volume takes care of that depth for you. As I mentioned, how I like to imagine it is that it finds the first contact, second contact, and it calculates the center, and it snaps your source object to that center. Another important caveat to remember is, let's say, instead of having a big plane in the middle, right, your object has a hole, right? So if you head into, oops, let me turn off view mode, go into global. If we go into orthographic side view mode, right, and you see this object now has a hole. So there will be a first contact, but no second contact. So when I try to snap the icosphere into the cube, what it does is it defaults to this, right? It snaps just to the center, I guess, to the center of your first contact, in this case, this face. However, let's say this cube no longer has a hole, right? And let's say we duplicate this cube and move it along the z-axis, right? We duplicate it 3 times. Now, heading into orthographic side view mode, if you try to snap this icosphere into the cube, what it's gonna do is only snap to the center of the first 2 contacts, right? So this is the first contact, this is the second contact, and it's gonna snap to the center. However, let's say we wanted to ignore the first contact, the second contact, and actually just snap to the center of the whole object. In this case, find the first contact and then find the last contact and snap right to the center of it. So it'd be somewhere around here, right? What we could do is enable an option called snap peel object, right? And so what that does is that it snaps to the center, right? It controls the depths of the whole object. In this case, it ignores the individual objects and it's gonna snap to the center of your whole object. So if you head into orthographic side view mode and we try to snap the icosphere into this cube, you could see that it no longer takes the first contact and the second contact. It actually takes the first contact and the last contact, and it finds the center. Again, I'm not sure if this is exactly how it's calculated, but this is how I like to imagine it. Also, when we're aligning to rotation with snapping to volume, in my testing, and I'm not exactly sure of this, but in my testing, it just aligns the z-coordinate to match the global space. In this case, to have z-coordinate just pointing upwards. So if we take this icosphere and just rotate it, oops, let me turn that off. If we just rotate it and apply rotation to deltas, you can now see that the z-coordinate is no longer pointing upwards. And when we snap to volume with align to rotation, you could see that it just moves it such that the z-coordinate is pointing upwards again. All right, moving on to snapping to edge center. To be honest, it's not that interesting. Same thing, it's very similar to snapping to edge, just that it snaps to the center of your edges now, right? Pretty simple. The interesting one, however, is snapping to edge perpendicular. And so how it works is that it snaps to the spot in the edge that will be perpendicular to the icosphere's movement. So, for example, if we head to side view and select the plane and extrude it just a little bit, right? You could see that this spot in the edge would be perpendicular to this icosphere's movement, right? So when we move ahead and snap the icosphere to the edge, you could see, let me erase the annotations. You could see that it snaps to the spot that is perpendicular to the icosphere's movement. And so if you look at a more complex example where we have this cube and this icosphere, moving the cube and snapping it to an edge in the icosphere, we could see that it snaps to this place in this particular edge of the icosphere. So if we try to draw the path of the cube, you can see it goes from the 3D cursor and forward to that spot in the edge in the icosphere. And if you draw that edge in the icosphere and hide the icosphere, you could see how it forms a perfectly perpendicular angle with that edge. You know, especially if you go down to top-down view, you can see how it forms a perfect right angle. Also, a cool little tip is that you can choose to snap to multiple different elements together. So I can select vertex and shift click to snap to edges too. So if I click the cylinder, as you can see, I'm snapping to edges first, but I can also snap to vertices. All right, we've looked at a lot of snapping types, but let's look at some of their applications. So we'll start with edge perpendicular, since this was the last one we've done. And a similar problem was posted on Stack Exchange, and I've answered it there, but I'll repeat it for the video. So hypothetically, let's say you have this trapezoid looking mesh, right? And what you want to do is you want to, from a point on this edge right here, so let me highlight it. From a point on this edge right here, you want to have a point, and from that point, draw a line to this second edge right here, such that the line is perpendicular to this second edge. And so what we'll do is approach it by using our knowledge about snapping to edge perpendicular. All right, to start, you just want to pick out your first point. So what I'm going to do is just pick out this edge and subdivide it, right? You know, it doesn't really matter where your point is, because we're just going to create a line that is perpendicular to that edge. So we know that snapping to edge perpendicular snaps to a spot in the edge that is perpendicular to the movement of the vertex. So in this case, if you just grab this edge, grab this vertex and extrude it to this edge over here, you'll see that it automatically snaps to the point in this edge that is perpendicular to that movement. However, as you can see, this edge is almost like an edge in space. It's not really connected to this face right here, right? It's not really connected. And so we can subdivide this edge and drag a point and snap it to this vertex, for example, but that's a little bit tedious, right? What we can do is, before making that edge, we can go over here to auto merge vertices and then enable split edges and faces. So now when we extrude this edge and snap it to this point and this edge over here, you could see that the face is automatically split, right? And so now you have basically two faces to play with an edge, as you can see over here, that is perfectly perpendicular to this edge over here. All right, so let's look at an application of vertex snapping. So hypothetically, let's say you have these two buildings over here, and you want to snap this building to this other building such that this vertex over here is snapped to this vertex over here. So they're basically right on top of each other, right? And so there's many ways to approach this problem, but I'll show you two. So the first way would be to select this building, right? And go into edit mode and select this vertex and change your vertex snapping to snap inactive. And you don't, in this case, you don't need project onto self. So what you can do is click A to select the rest of the mesh, and then you can just drag it over to this point over here. And as you can see, it automatically snaps using the active vertex. Now, the problem with this method is that it kind of leaves the origin behind, so you need to go back and fix the place of the origin if you'd like. Now, another way you can do this without changing or while keeping the origin intact with the mesh is going into edit mode and selecting this vertex and snapping the cursor to that vertex over here. Whoops. Let me only select this vertex and snapping the cursor to this vertex over here. And moving from edit mode and going to object mode and going back to the snapping menu and selecting center. And so what's that going to do is snap using the center of transformation. And basically what we're trying to do here is change the center of transformation from this origin point, because as you can see, our pivot point is set to median, and in object mode that refers to the origin. And so we want to change the center of transformation to the 3D cursor. So basically just change the pivot point to the 3D cursor. And as you can see, now this center of transformation is that 3D cursor. And then when you go ahead and snap to this vertex over here, you can see that it snaps exactly using the vertex we wanted. Finally, let's look at an application of face snapping. So let's say you have two cubes over here and you want to snap this face of the cube to this face such that they're perfectly flat, right? And so the only caveat here is that if we take this cube and rotate it all of a sudden and apply the rotation, now we can't really rely, or we can't automatically rely on using just face snapping and with align rotation turned on to snap the positive Z coordinate to this face. So there are many ways to approach this problem, but I'm going to show you two ways. So the first way is a way that I've seen in a YouTube channel called DECODED. And so basically what they did is they made a plane, right, and snapped it to this face over here. And then what you can do is, as you can see, if you click options and click origins, the Z coordinate is pointing that way, but we want to have it be pointing the opposite way in this direction. So then face snapping can take care of the rest and flip it and have it point in this direction, which is parallel to the normal of this face over here. So basically what we can do is turn on affect only origins and flip the object's local axis, only the local axis, using the local y-axis 180 degrees. And so what you can do next is just join this cube to this plane such that this cube inherits this plane's rotation. What you do next is just turn off affect only origins and snap this cube or snap the smaller cube to this bigger cube over here and just delete this plane. Simple as that. And so the second way, in which I think is a little bit more intuitive, is to think of it in terms of the object's local axis. So let's say we have a cube over here, we rotate it and apply rotation, and in this case we want this face to lie flat on this surface, right? So what we can do is go into edit mode, select this face, and make a new transform orientation out of it. Let's delete this one and make a new transform orientation out of that face. And what we can then do is go to object mode and click this transform orientation. Make sure it's clicked and select affect only origins. And then what we can do is, and when I discovered this, I thought it was pretty cool. So what we can do is go to object, transform, and align to transform orientation. So what's that going to do? Because we only have affect only origins, is transform the object's local axis to that new transform orientation that we made, right? And so basically what we got to do next is, you could see the y-axis. And so basically what we want to do is just flip the object's local axis 180 degrees. And then all that's left is to turn off affect only origins and snap this cube nicely onto this one. But as you can see, in this case, it's sinking a little bit down into the cube. And so what we can do is to avoid that is, instead of using the origin, we use this face. So snap this cursor to this face over here, select to snapping with the center, and then to click the 3D cursor as your pivot point. So in this case, instead of using the origin as our center of transformation, we're using the cursor and we're snapping using that center of transformation. So as you can see, when you click the cube, snap it onto this one, you could see it lies perfectly flat on this cube over here. Now for an application of snap to volume, I actually found a very cool video of how it applies to rigging that I'm going to link below. It's by a YouTube channel called CG Boost. It's really cool, it's really short, and it shows you how snapping to volume could be useful, especially when it comes to rigging. And that's about that. Important thing to remember that in this tutorial, I only covered the move part, how snapping works when you move an object, not how it works when you rotate or scale. For some of them, I'm sure you can figure it out on your own, but if there is enough interest, maybe I can make a video about them. That being said, I hope you enjoyed the video, and if you have any questions, drop them down below in the comments.